Hey guys, so today Sadie and I, probably Chance too, but we're going to teach you about sex-linked traits. Now, yeah, giggle giggle, we said sex, but what we're referring to here is gender. Certain diseases run more prevalently in a specific gender, and after you see how it breaks down through Punnett squares, you'll see why, and you'll know it'll make a lot of sense which gender is more prone to these disorders. Now, it doesn't mean that the other gender can't get them. It's just that it's much more likely that they're a carrier of that disease. They don't actually have it. Well, that's not really the correct way to say it. They do have the disease, but it doesn't make them ill. It's just in their body. If you remember, when we were talking about flus and viruses and bacteria with Typhoid Mary, she had that bacteria, Salmonella typhi, inside her body. It didn't make her sick though, but she could give it to other people. That's the carrier piece. This looks a little bit different though than in our bacteria and virus unit, where Typhoid Mary, if she came in contact with another person, that bacteria could come off of her body onto that person and make them sick. That's not how these types of disorders work. In order for a carrier to give off the virus, they need to reproduce. Their offspring can get it. That's the only way. All right, so let me turn on my screen share here, and I'll get us over to, where on earth? There it is. Okay. So we're going to be looking at sex-linked traits for your notes today. And again, you know me, I talk way too much, and my dogs are probably going to interrupt at least 3 times. So if you want to ignore me, go ahead, you can ignore me, and just copy these. All right, so we got some vocab to fill out at the beginning. Now, let me move me out of the way. So, sex chromosomes. Again, sex in this case, we're talking about gender. These are pairs 23. So if you remember that test 23andMe you'll see commercials for. What makes us human beings? We have 23 pairs of chromosomes. If you had 19 pairs of chromosomes, if you had chromosomes 1 through 19, you're not a person. What makes us human beings is that we have 23. If you have a different number, you're a different species than us. So that's why things like, you can't have an eagle and a snake have a baby, because when sperm and egg come together, they need to be matching amount. So to make a human, you need a sperm with 23 and an egg with 23. If you have a sperm with 7 and a sperm with 23, they can't make a baby. They're like specific locks and keys. They need the same amount. That's why Chance has come to join us. That's why it needs to be specifically human, on like only animals in the same genus can reproduce, because that's where you'll see that exact number. And if you have any extra information, like, if you have an extra number 2 chromosome, an extra 21, an extra 12, whatever, that's where our diseases come to be. So anyway, sex chromosomes. This is the last pair. When you are looking at, because there's a specific number, you have chromosome 1, 2, 3, 4. It's not like random ones that connect together. My chromosome 18 from my dad matched up with my 18 from my mom. My 9 matched up from my mom, matched up with my 9 from my dad. They look different. They're different widths, different sizes. They have different information on them. So a 23 can't match with a 4. It has to be the 23 and the 23rd and the 23rd. That's either going to be an X and an X, which would make you a female, or an X and a Y, which would make you a male. And every time, if you do the Punnett square later, put X and X on the top for mom, X and Y on the side for dad. Every time you have a baby, you have a 50% chance of boy or girl. So anyway, that's your sex chromosomes. We do that. That's how we sex a baby. That is a test that's done about, I think, 20 weeks in the pregnancy. They take a blood test and they can look at the baby's blood, and they see it. They line up its chromosomes, and if it's an XX, you got a little girl. XY, it's a little boy. So when they specifically carry a trait for disease, it's called a sex-linked disease. Now, there are specific diseases that on this X chromosome right here, something's a little wonky, they're a little weird. There's information missing, or there's too much information. And some of these diseases are things like muscular dystrophy, cystic fibrosis, Down syndrome, a couple pretty bad syndromes. But what happens is there's some information right here that's not right. And we'll explain why it's gender specific. But anyway, there's dominant inheritance. An abnormal gene is the dominant one. The child will be sick even when heterozygous. These are the bad diseases. If they're dominant disease inheritance. That means, so then we're going to think back, basically ignore everything we've done for non-Mendelian. They're not codominant. It's not like, each one's going to show up. If you have a sick like if you have a sick gene and an okay gene, you're sick and okay. If you have a sick and an okay, you're somewhere in the middle. Nothing like that. These are back to old school. So even if you have, let's say that it's dominant inheritance, that means that the dominant, if you have the dominant, you're sick. So if you have homozygous dominant, let's say it's for sick, big S, you're going to be sick. If it's heterozygous, big S, little s, you're still sick. Now, if it's, recessive, homozygous recessive, little s, then you would be healthy in that case. That's like a little bit more dangerous because then there's more genetics to make you sick. Where recessive inheritance is how most of these diseases go. And you're going to see more carriers. So that means if you're homozygous dominant, let's say in this case, being dominant is healthy. So in dominant inheritance, that means dominant is sick. If it's recessive inheritance, it means recessive is sick. And this is what you want, the recessive. So listen, in recessive inheritance, being healthy is dominant. We'll just say big H is dominant, healthy. If you're homozygous dominant, big H, that means that you are healthy, obviously. Now, here's where this carrier piece comes in. If you're big H, little h, you are completely fine. Because remember, in dominant inheritance, like I have brown eyes. But if I have a little b for blue, I can have a blue-eyed baby easily, even if the dad is not blue-eyed, because we have those recessive genes we can give to our babies. We're carriers of those genes. I can't like sneeze on you and give you blue eyes, but if I had a baby, that baby could have blue eyes. And that's how this inheritance works. And this is why in the beginning of this unit, we said, why does anybody need to know this stuff? Well, at the end of the day, there are certain things that could be hiding in your DNA, hiding in your chromosomes, that if you decide one day, or you accidentally one day, or whatever, who knows what the future brings for us. Hopefully we've learned enough that accidentally it doesn't happen. But if you have children, that recessive piece, that those hidden things inside our DNA can go on to the next generation. And that, it's another life that you've brought in that could have some type of recessive piece of DNA it gets from you. So these are all things to think about when that part of your life comes around where you want children. Or if you have, however that works out for you. But in this case, those carriers are the important thing to remember. So let's say let's say there's a disease hiding in my DNA on my X chromosome. If I have as long as I have a dominant, I'm not sick. If I have that little guy though, I could give, if that's the one my baby gets and my husband one day has the little one too, you're gonna have a sick baby. So that's stuff to remember. Now, carrier, again. So recessive inheritance just means that recessive means sick. Dominant inheritance means dominant means sick. So you're more likely to be sick in the dominant situation because 2 out of 3 genotypes make you sick. Where recessive, you only 1 out of the 3. You have to have homozygous recessive, little, to have the sickness, because dominant will knock it out every time. But carriers are created in recessive inheritance. Someone who holds the information for a disease in their genes or genetics, but does not express the side effects. This can be passed down to their offspring. So kind of think Typhoid Mary. Typhoid Mary was different because she had typhus living in her body, but it didn't make her sick. She was fine. If she went up to you and sneezed on you, touched you, whatever, made you food, it made you sick. That's not this kind of carrier. This is if you have babies, they can then take that information from your DNA. Remember, babies get half. Now, so just kind of a little reminder here. Humans, we just said this. We have 23 pairs of chromosomes. So you're writing 2, 3 right there. And in total, that means we have 46. We have a 1A, 1B. Well, we'll say 1M, 1D, mom, dad. 2M, 2D. 3M, 2D. 4M, 2D. All the way down to 23. And now these, what I was talking about before, these are homologous pairs. And if we remember, the prefix hetero means different, where homo means same. So let's like predict homologous pairs. If we mean the same pairs, that means that you need to have, if you look up here, 1 and 1 goes together, 2 and 2 gets together, 3 and 3, 4 and 4, 5 and 5, 6 and 6, 7 and 7, 8 and 8. Look at this 8 and 8. They both kind of move funky together. They're different lengths. They have different information. If you're homologous, that means the same exact one has to meet up with the same exact one. Now, let me move myself a little bit here so I can show you. Now, the only one that's not homologous is a boy over here. If you notice, the X and X stay together because they're literally the same chromosome. But if you get a little tiny Y, this guy right here, that makes you a boy. So technically they're kind of, see how all these guys are together, like 10 and 10, 11, 11, 12, 12, but X and Y have this gap. It's not a big deal. I mean, anything's wrong, just means you're male. But they're not homologous. You have two separate kinds. So if we're looking here, pair 23, we're going to review the idea of what your sex chromosomes are. So you have 23 pairs. This is where strictly in this class, we're not going to cover things like gender confusion or transgender identification, all those kind of things. That's a lot more complicated than this. Or if we're talking about being like non-binary, all that kind of stuff, like all different types of gender identification. There's so many things out there in the world that you'll experience. But for biology, we're just talking about biological gender. So what physical body are you born into? Because there is science behind all that stuff, but that'll just take too long to go through. So in this case, we're just talking about the biological gender. Basically, like, what junk do you have is basically what it is. So in this case, XX is female, XY is male. And remember, those diseases, when they're sex linked, are on the X, usually. Certain diseases only attach to the X chromosome. Like I said, pairs through 1 through 22 are called autosomes. They are always homologous. Auto means self. Like, think about a self-driving car. It's just going to do it. Autotroph, you don't have to, like, nothing has to really change. If you leave a plant in the sun, it's just going to feed itself. It's not going to, the only thing that's going to mess it up is nighttime or clouds. But the second there's sun, it's not like it speeds up or slows down. The second there's sun, it's doing it. Now with these 1 through 22, they self-pair. The second sperm and egg meet, they just find each other. They just, 4 and 4, 6 and 6, they just meet up with each other. That's what they do. Because if you notice, they look the same. Like this one, 15 has that little black band in the middle. 9 has it's like white, and there's 2 strips down here. I'm not a geneticist. I don't pretend that I know exactly what information is on each one. But there's some that I do know, like 21. If you have an extra 21, I believe that's Down syndrome. Extra 13, I think it's Turner syndrome. There's a bunch of different, I think you can get an extra 9. I forget what that one is, but there's a lot. Sometimes there are things called trisomy disorders, where what like people will say, like, I generally really don't like when people make jokes about like missing a chromosome. That doesn't happen. What can happen to egg and sperm when they come together is that we have every DNA molecule in our body has 23 pairs, except in our sperm if you're a boy, and egg, and if you're a girl. Now those have half the information, because think about it. When they come together, they make a full set. Now so they actually, like, they cut their DNA in half, and then they're ready to go together and make a baby. Because if you had 2 full sets, like if you had 2 full sets and you come together, now you got 4 pieces of information. You're not 46 chromosomes anymore. Now you're 46 pairs. I don't even know what animal that is. So that's not a human. Remember, 46 chromosomes is what makes us human. So if you have extras, that sperm and egg, if they don't cut their DNA in half and then become a sperm and an egg, there's so much. Think about like electricity. Too much electricity is a bad thing. It'll short out lights. It'll short out the computer. You don't want too much information in your DNA because your body just doesn't know what to do with all of that, and you get sick. Now, all of the other guys, those are those autosomes. They're automatically going to match up and be pairs. Anyway, let's get through this. Sorry, guys. You know me, yapping away. Now, X-linked recessive. If an X-linked disorder is recessive, women have an advantage over men. So there it is, guys. When it comes to which gender is most likely to have these diseases, it is men. Now, women, it doesn't mean we can't get it. What it means is that we are more likely to be carriers. It is possible, but it's less likely. Doesn't mean it doesn't happen. It's just less likely. But it is likely for women to carry these diseases. And I'll kind of explain that in a more simpler term in a second. So what that means, though, is that we can give it to our babies. It doesn't mean that we can't get it, but chances are we're fine. We don't look like we have these diseases, but we can have babies with them, especially if they're boys. So it's kind of like women's fault if the baby gets it a little bit. But anyway, so listen, if you remember, when it comes to pair 23, our sex chromosomes, our biological gender chromosomes, you can be XY, making you a boy, or XX. Women, we have an X and an X. We have two. And if you remember, the diseases that we're talking about here, they live on, and now remember, diseases mean lifelong. Infection means a short-term sickness you can battle. Diseases you just have your whole life. So these disorders live on the X. So I'm a female. I have two X's. If one of my X's is kind of messed up and it's got some of that bad information in there, that's some of that disease information, thank goodness I have a backup. I've got two. So if one of mine is messed up, my other one can be like, no, move out of the way. I'll take over. You're messing this up. Move. Let me fix it. In boys, their genotype to make you anatomically or like physically male are X and Y. So you only have one. If it's messed up, you're just messed up. There's no way, you don't have a backup X like I do to help fix it. So this one, Sadie, she's got two X's. Actually, I don't know how it works in dogs. And if she were a human, yeah, sorry, Chance, that's you, buddy. He's X and Y. If he had one of these diseases, like certain muscular dystrophies, cystic fibrosis, I think hemophilia works this way. There's a whole group of diseases that work this way. He would be in trouble. Chance would not be doing so hot because his X chromosome is messed up. It's all he's got. That's the only information his body can use. Sater Tater over here, she's got a backup X if one of hers is messed up, and that one can take over and kind of run the reins for her body if the one can't do it right. Now, if they had babies, the problem is if her baby's got her bad X, they'd be in trouble. They could be sick, especially if they're a boy, because remember, your Y chromosome comes from your dad. If you're an X and a Y, you can't get a Y chromosome from your mom. So Y comes from dad. So boys, your X chromosome comes from your mom. If you get her bad one, then you're sick. Hopefully, you would get that strong, dominant, healthy X chromosome from mom. Make sense? All right. So listen, so if you're a boy, you have a 50-50 chance of getting that bad genetics if your mom has this disease in her DNA. Now, if she's sick, you 100% are going to get it because that means both of her X's are messed up. Now, if she's a carrier, you have a 50-50 shot because she has one healthy, one bad. I hope that makes sense. If not, I'm throwing a lot of information at you. Hit me up on Google Hangout. I'll break these specific pieces down, especially if you just have more questions. There's a lot of cool stuff to think about when it comes to things. Because I said earlier, this stuff's important to know because, if you want to have babies, but also, you are somebody's baby. So all of this stuff could be happening inside your body. Or, not necessarily, I don't want to be like, oh, you all have these diseases. No, you don't have these things. You would have known at birth with these kind of diseases. But, this is stuff that happens inside your DNA. This is who you came from is your parents, regardless of what role they play in your life. You know, you literally are made from your parents' DNA. So half of this stuff, you know, your Y came from your dad, your X came from your mom if you're a boy. You know, it's complicated stuff. All right. Anyway, so women that are heterozygous for the disorder are called carriers. Like I said, if she has if Mama Sadie over here has a strong, healthy, dominant X and then a weak, recessive, sick X, she's that heterozygous, dominant and recessive. She's now a carrier. She doesn't have it. She's not sick, but her sons really got to watch out, because if they take her weak X, they're gonna be sick. So it is rare for women to have these diseases, common for them to be carriers. That's the thing. It's very rare to have this disorder as a woman. It's not rare though to carry them. So this is something like a lot of females should think about. All right, so let me move myself again. So in this case, now I did coefficients here. If this is confusing for you, let me pull out of this here real quick. How you can also look at this is HH. We can look at this in terms of our normal. Now there's two ways you can look at, let me make this green real quick. I think this is the same green. If it's not, sorry guys. Let me fix this up for you. Okay, let's go back into present here. So there's two ways you can look at this. I put this the coefficient way. This literally means the same thing as this. This just means on the X chromosome, you were healthy. On the X chromosome, you were healthy. The X chromosome, it was healthy. X chromosome, it was sick. When you do like keystones and CDTs, you're going to see a lot of this setup. It literally means the same thing. So you're good. This is just telling you that the coefficient here, this X, is what gene they're talking about. And then up here is your allele. The exponent is what version of the allele you have, dominant or recessive. So listen, in females, if you have two, like we said this, I kind of said this like 3 times now at this point, but if you have 2 of those unhealthy X chromosomes, so let's say Daddy Chance over here and Mama Sadie have babies. If he is sick and his X is messed up, and you get unlucky, let's say she's a carrier, and you get her bad X also, that means you are going to be sick as a female of your XX. So now healthy, of course, if you get 2 good, healthy X's, you're fine. Now, if you, in this case, remember, if Chance is the one that's sick, he gives you this sick X to work with. But, you know, Sadie, you got lucky, you got her healthy X, this heterozygous combination of big H, little h, H meaning healthy, you're still healthy. But your babies one day, if they're babies, if I become a grandmommy to their, or I guess it'd be great grandmommy to their puppies, right here, if this is the one that they get from that baby, their kids could be sick. So again, this is that healthy carrier. This female is just healthy. Now this female is sick. So females have a 1 out of 3 chance. It's not really, it's a lot less than that. But if you just look out of the top, the possible genotypes, phenotypes, 1 out of 3 will make you sick. This is very unlikely in reality because of these types of diseases. And the people that get them, their chances of reproduction are a little bit lower. So if a male were to be affected, it's not likely they would reproduce. So you wouldn't likely be able to get that X from him. Now, in this case, now we're looking at the male combo. Females have 3 genotypes to work with. Boys only have 2. Because you only have 1 X. So if a man inherits a recessive trait, it's the only X you have. You cannot be a carrier. No matter what, you have it or you don't. Because again, remember, I have a backup X. If my X, we'll go back real quick. Let's say I'm her. Let's say for cystic fibrosis. If I'm a carrier, I'm not sick. I'm good. I have it in my body, but I'm not sick from it. I don't have a single symptom. I don't have it, nothing. It's hiding in my body because my dominant one was like, get out of here. What are you doing here? Move. I'm going to deal with this. You're annoying. Go away. I'm going to run the show. I'm dominant. I'm stronger. But with boys, that's not how it works. If you have, you can't have one hide. It's the only one you can work with. So if it's sick, you're sick. So that's why these diseases, you see them in boys. You don't really see them in females. In what situation would it be least likely to pass down a sex-linked disease? So if we were to Punnett square this up, I'm trying to think. I gotta look at your notes real quick to see if you have boxes or if you just have to, if this picture is written for you. But if you think about it, if you have an unaffected father, so he's healthy, and the mom is heterozygous, like we said, it is for the females, no matter what, they're not going to have it because their dad's X is healthy. So one of their X's is healthy, they're going to be fine. Now, of the daughters, even if they get mom's kind of messed up H or that sick X, they're going to hide it. They're going to be fine. Where sons, literally half of them are going to be sick. Because you have a 50-50 chance if you're a boy, because again, if you get mom's X and it's messed up, it's the only one you have. All right, so when it comes to the notes, let me look at these real quick, because we're going to skip these since it's a little pain in the butt to do these on your, sorry, Sadie's grumbling at me. It's a little pain in the butt to do these on the computer, so we're going to kind of skip over that. So in conclusion, real quick, let's look at these notes. Who was most likely to have a sex-linked trait? Boys, unfortunately, because again, you don't have a backup to help you if you're sick. Who is most likely to pass down? Women, because we can be carriers. Sex-linked traits are nicknamed the male-only traits. These are things that, like I said, technically it's a 1 out of 3 combo for females to be sick with it, but in reality it's much less than that, because yes, it's 1 out of 3 possibilities, but statistically it's very, very rare for females to have a father with one of these diseases. Now here's some of them. Color blindness, hemophilia, which we talked about before. Remember that hemo meaning blood, people whose blood don't clot. Again, that is historically, nowadays it's a little more, it's much more survivable than it used to be, but still a very dangerous disease, because just something as simple as think how many times little kids fall and get bruises. If bruises never stop bleeding, they can die from internal bleeding. But we have medicine now to fix that, where back in 50 and 100 years ago and farther back, you didn't really survive that. There was nothing to like really stop your bleeding. Duchenne muscular dystrophy is a little bit different than ALS, but it is in the same group of disorders. Now, hemophilia, we talked about this a little bit. They call this the royal disease. Because of traditional inbreeding, this disease affected many men of royalty throughout Germany, and a lot of actually other European countries where they only, when you think about it, we've talked about this before, the reason inbreeding is bad is because if you have all of the same genes just breeding together, that means any flaw that's in there, it's just going to keep going, because there's no other types of genes coming in to wash it out. Like we said, like if every woman is a carrier and every man has a disease, no matter what, every boy's going to have it, because that bad gene is not leaving the gene pool. There's no new genes to mix it up. So in this case, we talked about this a little bit, so I'm not going to take too much time to talk about this, but sufferers are missing platelets. Platelets are not actually a blood cell themselves. They're little fragments of blood that are flat, and they're like the internal band-aids. They travel through our veins, they travel through our arteries, and they'll like kind of plug up a hole from the inside. It's a very risk of bleeding, very, very serious risk of bleeding to death, especially as a young child, like a toddler. And this is extremely rare in women. We talked about the Romanov family. Not a single female had it, but their only son, they had 3 girls and a boy. Not a single girl had it. They're probably carriers, but their only son had it. And I keep forgetting we already talked about these guys, but here's a quick run through real quick. The royal family of Russia, from 1613 to 1918, around the time of World War I, a group called the Bolsheviks, led by Vladimir Lenin. Now, these guys were kind of like the ones who started communist Russia. They began rising up against the Romanovs. They were upset because basically, long story short, royalty, remember they had that like 1,000-room palace. They had like 5 homes and each one was a castle. Well, the rich were very, very rich and extravagant, and the average Russian was dying of starvation. And their children died. They like childbirth. Many women died from that. You had starvation everywhere. But what the Bolsheviks felt, the wealth gap was unjust and wanted to spread some of the royal wealth to the poorer parts of Russia. Now, the average person made it $1.90 a day at this time. So in a week, you're not even making $10 if you were to make it modern times. That's the average Russian person. I'm not talking just the homeless people. This is like, so like I'd be an average Russian person with the amount of money I make. Not even $10 a week is how much money I'd be so homeless. It'd be crazy. Where what they were thinking is that if we took just like one dinner the Romanovs had and spread it a week, everybody would be so much healthier. And we watched this already. If you would like to look it up, you can play it and kind of refresh your brain of what happened to this family. And again, hemophilia. There's that crazy Rasputin guy. Remember the doctor that they trusted because of their son's hemophilia? There's no more royalty in Russia. And some people could say, especially us nerdy biology, virology, scientist people, you could say hemophilia is the reason there's no more royal family and is the reason it's communist in Russia. All right, that's it, guys. We are tomorrow. I'm kind of decide how I want to do this. We're probably, I do want you guys to look up specific sex-linked genetic disorders. I'll figure out how I want to do it. Just so it's easier for you guys. So if you have any input on what you think would be easier for making, we were going to do poster projects. Obviously can't do that. But if you like, there's PowerPoints, or maybe if you guys like want to make a poster and send me pictures of it, give me some feedback. What do you think would be best to present some research? Miss you guys. I hope you're staying well. Go outside, take walks, get some sun. It's coming. The rest of the week's kind of burnt, but this weekend's gonna be beautiful. I hope you're doing well. Do things that make you happy. Being inside sucks. I get it. I feel like my apartment is getting smaller every day. But we're in this together, and it'll be over soon. And hang in there. I miss you guys. Bye.